Hi, I'm Russell Hancock. I'm going to give a speech or presentation on using the database to speed up development. It's only a very brief over-the-top view of kind of general concepts. If there's any interest, I'll do a further one a bit more in detail. But I wanted to try and present this at both business case level and kind of technical level somehow. So you might understand some bits, you might not. We'll see how we get on. So what am I going to do? I'm a big fan of database. I like using databases. I like being down at that level and doing stuff. I'm not so fussy on doing the JavaScript front end stuff. I like being down at the bottom level. So over the time, I've kind of found ways to fix problems down at that level because that's where I like being. And actually, I think you can save a lot of time being down there if you know what you're doing. So I'm going to explain how you can use kind of a couple of general features just to solve a couple of business problems. They're actual real-world business problems that I've solved previously and are currently live software. I'm then going to look at ways you can use the database to speed out deployment. Look at a couple of simple tools that are included as part of SQL Server, so I will get specific to SQL Server at that point. And then we'll see how we get on there. So MVC, great framework. Model view controller. You model your data, it's all there for you. Generally, I'm not a big fan of using lots of frameworks. I understand people use Entity Framework with this, it does its job. A lot of the things today, where I'm saying do stuff in the database, could be done in the model component in MVC. I think it's simpler to put it in the database, but it's each to their own on that. I'm not going to tell you you're right or wrong. I think you're wrong, but I'm not going to tell you that. I'm just going to get on with kind of what you can do in the database level and see how we get on. So MVC, I know it exists. I know it's very popular. I know you can do it in there. This is another option. And actually, I think it's a suitable option. So I'm going to look at two common business problems of what most businesses need to do. It's one of the aims you have to do. So I'm going to look at auditing and I'm going to look at debugging. So auditing what's happening, knowing what changes have gone on in your system, being able to look back and say, oh, actually, the one I'm going to get into is stock control system. So, oh, how did we get an order where we don't have the stock in? How's that happened? Or, oh, why didn't that order go out? Have we missed something? So you need to be able to go back and look at your code and say, well, why didn't things work? They're just two of the areas I'm going to look at. But they're two of the easiest ones to cover. It can be used in loads of other areas, but these are two of the easiest ones to look at. And they're two of the most common business requirements I know of. So auditing of changes. How can we get the database to keep a record of all the changes? How can you do something in one step that does everything for you, so you don't have to look at it? It's triggers. Who uses triggers in the database? That's a resounding silence. So one of the ones that I like using the most is an after update. It only ever fires if you've changed something. Therefore, you don't have to do any code handling to know whether something's changed or not. You only get this event if something's changed. Therefore, you need to audit it. So actually, 50% of the code, 50% of the logic is done for you. So you can have a trigger that purely runs, not on insert, purely on update. And this is one, right here. Lovely code. What this is doing, it's a two-part one. It covers actually both the issues. This is a stock control one. This bit here is purely used to record the fact that a stock level has changed. It simply sticks a record in a table, and by doing that, that actually keeps in check 8 different business processes, just with that one bit. There's stock control on 4 different systems. There's returns, there's stock taking, there's on-site in the shop, the tills from them, and that records that one. This one actually covers all the auditing. This actually sticks in the database, and it's a bit higgledy-piggledy, but stock level changed from the old value to the new value. And it does this using deleted and inserted. They're two kind of magical little records that exist in the database. One is what was there before, one is what's the new record going in. So the inserted is what you're adding in, the deleted is what was there before. And actually, you can use a very simple check, which is, I took them into local variables there, but you can actually say if they don't match up, do these things. So, I can't see all my notes on that, it's very annoying. Oh, is this one not touchy? Aha. That explains it. So, having these in place, I don't need to worry about any new systems coming online, any new, creating a mobile app for people to do orders. We all have Amazon app on our phone. We all order stuff quickly on the phone, press a button. We can put in any new route in, any new channel to sales, and we don't have to worry about doing any stock level auditing because this all happens in the database. Every time we do anything, all this automatically happens. And I know you can achieve similar things by putting a controller in the front end, putting all the logic in the MVC block there and passing it down. But actually, you've got to test that bit. And you've got to deploy that bit every time. You've got to build that bit every time. Once it's in the database, it's in, it's done, it's out the way. One of the other things this helps with is actually testing and debugging. With this, I don't actually have to really run any debugging tests or anything. All I need to do is look in the database and see, do I get a record that says changed from X to Y? I know I've said I've sold 2 of them, so does the result I get go from what I knew was in the database to being 2 lower? But actually, yes, it does. So I know all the business logic up above it all works. And because this is really, really simple and human readable, you don't need to sit there and pick through massive log files. You don't need to worry if it goes wrong, why it went wrong. You can actually just look at it and you've got all the history in date order as it went through. And you can see, it changed from 4 to 5 because I added 1. It changed from 5 to 3 because we sold 2. Oh, someone returned 1, it went back up to 4. You can actually just look at it and see it. You don't need to sit there and pick through extensive logs or anything like that. It's all in human readable form. So actually, it kind of helps with a bit of the debugging at that point too. So this, you might think, actually, okay, it fixes debugging too. That bit of code, how long do you think it would take to actually write that and deploy that bit of code? So I've made a change. I've decided to change the wording of the stock level auditing from saying from 4 to 5. I've now said from 4 to 5 on the 23rd of January. How long do you think it takes to actually apply that change? Less than a second. The database is really, really quick at applying changes. It's actually, it makes life easy. And the other thing I like about it, if we look at it, it's kind of readable. I know to the non-techies in here, that is not readable in any way, shape, or form. But actually, if we look at the key points of it, create a trigger, after update, insert into, where the stock's not the same, and then insert into the event, where the stock's not the same. You can actually sit there and read it. You can check that what you're deploying is actually what you want to happen, because you can read it. It's English. So one of the great things about SQL is it is actually human readable. It was designed to be that way. And so when you're rolling out all these changes, when you're doing this new deployment, you've not got binary files that are compiled and you can't really tell what's going on in there. And actually, we've all done it. We've compiled something and realised that we changed a setting and forgotten it's hidden in the binary file now, and actually you deploy it and it doesn't quite work, so you've got to roll it back and do it again. You can actually see it here. There is no hidden coding. And it just, you press a button and it happens and you know it's going to be right because you just read it. It also gives you a single controlled rollout. Now I know, again, having MVC, one single website, it's there. Generally you end up with quite a few web servers underneath a site if it's of any significant scale. You don't just have one server, you have multiple for redundancy. You've got to deploy to each of them, you've got to take them in and out of the load balancing, you've got to take them in and out of the firewalls, you've got to make sure all the users run down. On the database, even if it's clustered, actually the way SQL behaves is that you apply it once, it applies everywhere instantly. So again, you've still got to do rollout deployment, you've still got to make sure you're not going to trip anyone up. But because you're applying it at the bottom level and it applies basically instantaneously, there's very, very little downtime. There's very little chance of it going wrong. You can't have a file miscopy. You can't have a connection drop out halfway through. Once you fire it, it runs on the server. It's not waiting for 20 files to upload. It's not waiting for a load of binary files to get up. Your internet suddenly slowed down. None of that matters. It's a text string that gets shoved up to the server and it gets rolled out. The other thing that I've had problems with in the past, which is why we end up at the database level, is things like if you update stuff in an Android app or an Apple app, you've got to wait for Google to approve it. You've got to wait for Google to deploy it. You've got to wait for everyone's auto-update settings to happen. Now, I don't know about everyone else here, but my phone, I've got it set to auto-update apps. Half of them don't update because they want new permissions. So I'm using an app that's 3 or 4 versions old. If you find a security hole and you've got to wait for that to update and people to actually do it, you're not going to be able to roll out. You can't force the update. Doing it at the database level, that's fully in your control. You can change it there and then, and you know it's deployed. The second you press run, the second you press commit that change, it has happened, and that security hole is gone. If you've got it hidden up in some code on an MVC level, or even some code that's gone out in an Android app or an iOS app, you've got to wait for every single user to churn through the updates and actually update it. So I think that's why it's a better place to put it. I'm going to move on to a couple of tools that are built into SQL Server that actually help you do some of these things and help you to understand what you're doing and make your life easier. So what tools make your life easier? That makes your life easier. Like them. I also like them. I want one of them. I want to be that person sat there chilling out whilst my lawn's cut for me, because I hate mowing my lawn. It's annoying. SQL Server Profiler. Now, this is one of my favourite ways of finding out what's going on. It looks very ugly. Horrible UI. This is from some time before the dinosaurs, I think. But what it does do is it tells you every single thing that is happening on your database. Now, I've had a link query that was going stupid on one of the projects we did. Couldn't figure out why it wasn't doing what it was doing. Ran SQL Profile to see what it was actually sending to the server, and it had misunderstood one of the joins. One of the models had been created wrong, and it was misjoining, and it was sending the incorrect data, which was causing everything to go wrong. We couldn't tell at the top end because the link statement was correct, and we couldn't see what it was actually building underneath through the MVC stuff to actually see what it was sending to the server. This actually told us, this is the statement I'm running, and the variables it put in there, and that's how we actually figured out what was going on. This is built into SQL Server Management Studio, Tools, SQL Profiler. It's that easy. It's in there, and you can set it to filter for certain usernames or certain event types or anything like that. So actually, if you're ever having problems with the incorrect data going in, this is one of the best ways of finding out what's actually being pushed to the database. The other one I like is execution plans. The amount of times I've sat down and heard people say, oh, this query's taking a really long time. Well, actually, this tells you what it's going to do. So it's going to, this was a select from, you can see the statement up here, select from products, inner join options on the IDs. So the inner join is going to take 3% of the time. Scanning the index on products is going to take 25% of the time. Ordering it's 50% of the time. Okay. Well, actually, do we need to order it at that point? That's going to take 50% of our execution time. Do we need to worry about ordering it yet? Or do we need to worry about ordering it later? And actually, what this will do, even on a simple query like this one, where I haven't done an order, it's telling me it's going to do an order. So I can reduce that time by specifying the order, an order by clause that the database is already ordering in. So I do an order by ID because that's the way it's ordered in the database, and that would reduce the runtime. So actually, if you are doing stuff in the database and you run a query and it takes 2, 3, 4 minutes to return, you can stick it in here, you can press execution plan, and it will tell you what it thinks it's going to do. And then this one is actually what it did. I haven't got a screenshot of that one, annoyingly. I forgot to do that screenshot. But actually, this took 7 seconds to run. Way too long for a simple join. There's only 12,500 records in there. And I now know why it's taking so long, and I can get rid of 3 seconds of that and halve it. So actually, just by using this, and this is in SQL Management Studio, it's just a button at the top you press, and it will show you the execution plan that it's planning on doing. And by using those 2 tools that have gone on about, and actually having triggers in the database. If you do it all down at that level, you can see it all, and actually you can run this live. You can run this on your live server, under load, you can run the select statement, and you can see how long it takes. And it doesn't impact on any of your live users because it's just another query. And actually, it doesn't, you don't have to roll out debug versions, you don't have to roll out logging, you don't have to have anything else in place. You literally just connect to your server as if you were using it, and you press that button, and you can see what's going on, and you can get the live stats. And actually, it used 50% of the time here. It didn't like the join for some reason. It lied here. But again, seeing that, I knew that I haven't actually put a link on those two fields so it understands, so I can actually make it quicker as well another way. So after playing with it, I can get it down to about a second from 7 seconds originally. So I think that having those tools available actually, with the power of what's going on behind, makes things a lot easier. And it makes it easier to deploy, it makes it easier to test, it makes it easier to code, it makes it easier to find issues and fix them. And yeah, that's my thoughts on that. I have only gone into very, very simple concepts there. With the triggers, I've done an after update. There's an instead of update. You can tell it not to actually update that table ever. You can tell it to take the inserted values and stick them somewhere else. You can do an instead of insert. You can have a trigger that only runs on inserts instead of only on updates. You can have a trigger that runs on both. There are so many options in that level that you can do that actually, other options for speeding things up. There's also things like stored procedures, scalar value functions, where you can put common business logic that you always want to do into the database, deploy it once, have it there, and it's done. And actually, if you think about it, if you've put half the logic in here, they're all individual statements you can read, you can see them all. How long do any of you use continuous delivery? So continuous build pipeline. How long do the builds normally take? Are we talking minutes, 10 minutes, 15 minutes, 5 minutes? If you take half the stuff out of there, you've halved the build time. Now with each build, you've got to run the testing. Now, I know in all of the automated testing I did on that stock control system, I never had to worry, did it actually update the other systems? Because I knew for a fact every time it did, because it was in the database and it happened automatically. So I cut out half my unit testing and functional testing. I cut out half my build time and my deployment time. I cut out half the possibility of issues going live when I put it live. So I think they're really good. There's other things we could look in, things like full text indexing for fuzzy searching, things like that. They're all built in. They're actually really quick, depending on your data load. You can do performance tuning, as we've shown. There's slightly more advanced ways to do it. There's other things like version auditing and things like that that you can do with a trigger on the database, where you increment a unique ID, so it always increments, so you know which ones are the newest. Or you can put a last updated timestamp, where you can do that in a trigger every time. You don't have to worry about doing it in code, and it's always the right time because you don't end up with the browser sending through a US time rather than a UK time, or someone not setting up a database connection properly, or something like that. Because it's always done at the database level, it's always right. So there are more things you can go on to, but most you'll be pleased to hear that's me wittering about database done.